All right, number 10, an escalator that is 1,090 feet, 90.2 feet long, drops a vertical distance of 196.6 feet. What is the angle of depression? All right, so we have an escalator, kind of like some stairs going up, whatever. And they're telling us how long it is. So how long is going to be the slant height? Has a vertical drop of 196.6, and this distance is 1090.2. And then we want to know what is the angle of depression. So I got to make this box so I can make it all work out. So the angle of depression comes from the horizontal going downward, okay, or elevation would go upward. So we want to know what this angle is here. So we have from this angle 196. If you make this box, this is also 196.6. So we have opposite and hypotenuse. You see this as a right triangle. This is the opposite side, hypotenuse. The trig function that uses opposite and hypotenuse is sine. So we have to do sine of theta equals opposite 196.6 over hypotenuse 1090.2. And then we got to do the inverse sine to figure out theta. So theta equals inverse sine of 196.6 over 1090.2. All right, so we're going to compute that. So we're going to do 196.6 divided by 1090.2. And then we're going to do the inverse sine. So second inverse sine of that. That does not seem right. Let's try that again. Let's just do it in parentheses first. 196.6 divided by 1090.2. And then we're going to do inverse sine of that. So it looks like 10.38, and that will round up to 10.4. So theta is approximately 10.4. All right, number 11. We got a window washer on the ladder. Looks at a nearby building 100 feet away, noting that the angle of elevation to the top is 17.1. The angle of depression to the bottom is 5.2. How tall is the building? Okay, so we have this image. I'm going to give you the image of a right triangle here in both cases. This angle, so here's a guy, this angle going up from the horizontal is 17.1. This angle coming down is 5.2. And this total distance is 100 feet. We want to know the total distance, so we're going to call that X, this is Y. So from here down and that up. So from this angle, we have opposite and adjacent, so we need tangent, opposite over adjacent. So tangent of 17.1 equals opposite, which is x, I don't know, over adjacent. And I'm going to go ahead and set up the other one. This angle we have opposite and still adjacent. So opposite over adjacent, we're going to do tangent (5.2 degrees) equals opposite, which will be y, over adjacent, which is 100. The height of the building will be the addition of both of these. So we can figure this out by multiplying by 100. 110 of 17.1 is the x value, and then times 100, we get 100 times 10 of 5.2 equals y. So I'm going to figure out both of these and add them together. Okay. That will give me the total height of the building. All right, so we're going to do 17.1. Let's clear everything out. 17.1. We're going to do the tangent of that times 100. Times 100. Okay. So that gives us, let me just write down a few places. 30.76401. Let's just round it up to a 7. Okay. The more places you use, the better, because you don't want to round to the very end. So the more places I use is going to help me out with the rounding, because these are not whole numbers. All right, now we're going to do this one. So 5.2, we're going to do tangent, and then we're going to times 100. And that gives us 9.1007. 9.1007.129. Okay, so we need to add these two up, the height of x and y, and that will give us our height of the building. We want to round to the nearest foot, so we're going to round to the nearest whole number. So the fact that we have several decimal places definitely helps. So this number is already in there. So I'm just going to add 30.764017 and round it to the nearest foot. Whole number will be about 40 feet high. So rounding that, let me make sure. 39.8. And that'll round up to about 40 feet. Because we're on a whole number. Sorry, I can't see what I'm writing down there. 39.8, and that rounds to about 40 feet as a whole number.